Hey you guys, today we're going to talk a little bit about the graphs of logarithmic functions. So we did a sketch of what a log function looks like on our last lesson. So here is just a general sketch of f of x equals the log base b of x. Some characteristics of the graph of the log function is the x-intercept is 1, 0. Remember how we talked about the logarithm function being the inverse of the exponential function. And remember, it had a y-intercept of 0, 1. And if you switch those two numbers like you do with an inverse, that's how you get this x-intercept of 1, 0. It doesn't have a y-intercept because the y-axis is an asymptote. And remember, with an exponential function, the x-axis is an asymptote. It's a smooth and continuous curve. If your base, this little b here, if your base for the logarithm is a number greater than 1, then it's going to be increasing. That means from left to right, when you read this graph, it's going to head towards positive infinity. And if b is a fraction or decimal between 0 and 1, like a quarter or a half or 0.378, whatever, then it's going to be decreasing. So it will head down towards negative infinity as you go from left to right. All right, so let's talk about how to graph logs with bases other than 10 or e on your TI-84, okay? So all you have to do, sorry about that. Of course, you got to turn it on. You go to y equals first, and then to get to the log where you get to pick the base, you hit alpha and then window. And then you'll hit number 5. It says log base. And see right there, you can put in any number you want for the base, and then whatever goes here, right? And then you would just hit graph, and it would show you what the graph looks like. And remember, to get to the table, you hit second and graph. So let's just graph and sketch a couple examples of these things. So let's look at the log base 2 of x. So I've got that pulled up from where I did it before. So for the base, I'm going to put 2, and over here in parentheses, I just scooch over, and I'm going to put x and hit enter, and then press graph. Now, b is a number greater than 1, then I expect it will be increasing. And if we look, it's increasing, right? So I'm just going to sketch that. Two would go up to 1. Again, it has a it has an x-intercept of 1. No y-intercept because the y-axis is an asymptote. Okay, so it's increasing because my base b is 2, and 2 is greater than 1. All right, let's look at log base of 4th of x. So I'm going to go back to y equals, clear that out. I'm going to go alpha, window, and pick number 5. For the base, I'm going to put 0.25 because it's a quarter. Scooch over, put my x in there, and hit graph. Now my base is a fraction between 0 and 1, so this will be decreasing, right? And look, we can see that it's decreasing. Just going to sketch that. Okay, so that's really all you need to keep in mind. This is bigger than 1, increasing, between 0 and 1, decreasing. Now, all those rules you learned about transformation still apply. So if I stick a number out front here, it can be a vertical stretch or compression. If I stick a negative out front, what happens? It reflects it over the x-axis. If I stick a negative in front of this x, what happens? It'll reflect it over the y-axis. If I add or subtract a number in here, it'll move it left or right. If I add or subtract a number on the end, it'll move it up or down. So just keep those things in mind. I fully expect you to graph these on a calculator. If you don't have access to one of these, I'm a huge fan of Desmos, which you can download as an app, or you can go to online on your computers. All right, let's talk about the domain of a logarithmic function. So the domain for just your regular log function is the set of all positive real numbers. And like I said, that's just for f of x is log base anything of x, okay? But if you go adding and subtracting and multiplying stuff inside of here, then the domain will be all the real numbers such that and I use g of x is greater than 0. So just whatever comes after, whatever's in the parentheses after the base, you just want to take that and set it greater than 0. Okay? That's all you have to do. It is not crazy at all. You ready to try a few? Okay, so let's look at the first one. We got the f of x equals log base 4 of x minus 5. So all you want to do is take this good stuff right here, and you want to set it to be greater than 0. Got to be greater than 0. I can only take the log of positive stuff. Logs are positive. So to get rid of this minus 5, I add 5. And of course 0 plus 5 is 5. So we get x is greater than 5. So let's write that using set notation. So we start at 5. Greater than 5, we would go up to infinity. Now I'm using a parenthesis because we don't use the equal to part. So it's not included. 5 is not part of the domain. It's every number bigger than 5 and up. Okay? All right, let's look at the second one. We have the log base 3 of 2x minus 7. So all we got to do is take this 2x minus 7, and we want that to be greater than 0. And then we solve. So I'm going to add 7. Here we get 2x is greater than 7. Divide by 2. And you can leave it as a fraction, or if you want to, you can change that to 3.5 as a decimal. So all the numbers bigger than 7 halves. So I will start at 7 halves. And I will go up to infinity. And that's it. All right, the last one is a little tricky, but not too bad. You guys totally can do this. So we have negative 3x plus 6. So I want negative 3x plus 6 to be greater than 0. So I'm going to solve this. Subtract 6. We get negative 3x is going to be greater than negative 6. Now, to isolate x, I'm going to have to divide by a negative 3. And if you guys will remember, when you learned about solving inequalities, if you divide or multiply by a negative on both sides, then you have to flip or reverse the inequality symbol. So, and then negative 6 divided by negative 3 is 2. So this will be all the real numbers less than 2. So 2 up to 2 is as big as we can get. So that'll be from negative infinity up to 2 is my domain for that log function. Okay? All right. I hope you guys have a great day.